Thank you so much for joining us today for our Smart Water Meter Operations webinar. We're very excited to have you here. Before we get started, just a quick housekeeping note. Please feel free to drop any questions that you have into the Q&A chat box at the bottom of your Zoom screen as we go along, and we're going to reach out to everybody directly by email to answer them right after the webinar. So let me start by introducing today's speakers. Charlie Nobles is Terrago's VP of Sales, bringing extensive expertise in AMI, smart grid modernization, and connected lighting solutions, shaped by leadership roles at Ubiquia, Sensus, and Duke Energy, where he drove large-scale grid and metering transformations across the US and Europe. And Jeff Ross serves as the VP of Enterprise Solutions at Terrago, where he helps utilities and municipalities transform field operations through connected infrastructure solutions, drawing on more than 25 years of hands-on experience deploying and scaling smart lighting, IoT, and smart grid technologies. So with that, I will go ahead and turn it over to Jeff to kick things off.
Great. Thanks, Madison. Uh, let's start off with just one quick slide about who Terrago is. If you're not familiar with Terrago at all, we're a 20-plus-year-old software company based out of the Washington, D.C. area. We're primarily focused on operations software, right? So we offer a full platform for full life cycle management of infrastructure assets, a very operational view. Um, we're a little bit different than a traditional kind of player in this world. We offer what's called a no-code platform. If you're unfamiliar with what no-code means, what that means is our platform is configured for each one of our customers. So if you look at the millions and millions of assets that are on our platform today, over hundreds of customers, each individual implementation is slightly different. A lot of commonalities, but each one is specifically implemented for them based off of their needs, their terminology, their language, if it's international, based off of the colors and schema and business rules and the logic they want. So it enables us to really quickly deploy a solution for a utility and then adapt it, customize it specifically for them never writing any code whatsoever, just configuring the platform. The reason why I always point this out is because it's very different than what a traditional product company is. For utilities, I think they're used to system integrators and product companies in which they've got a change they'd like to make. They bring that back to the integrator nickels and dimes them on the charges for that, and or the product company comes back and says, okay, we'll get that into a roadmap, maybe we can get that done in, I don't know, 6 months, 3 quarters, something like that. When a customer says they want to make a change, we implement that change sometimes within hours, sometimes within days. If it's a very large change, maybe a couple of weeks. It's a very different way that utilities are adapting our platform to enable them to really quickly deploy something and constantly iterate and improve upon that solution. If you want any information about Terrago outside of just water meters in terms of how we're used for, you name it, on the electrical grid side, things like street lights, DA devices, joint use, pole attachments, command center from an operational view, please reach out to us. We're glad to get back to you with more information about Terrago, the company, as well as Terrago, the platform. All right, let's jump into the next slide, Madison, and talk about water AMI a bit. What we've really noticed in water AMI, and this is the same trend we really saw years ago on the electrical side as well, is that oftentimes technology is focused specifically on the systems and the connectivity and the data flow. So in water AMI specifically, this is a standard architectural drawing that many of you are probably used to seeing, where the focus is on who's the meter manufacturer, what are the capabilities of that meter? Well, what's the communication, meaning the endpoint? How does that thing communicate, and over what network does it communicate on? Is it an IPv6 based network? Is it LoRa? Is it cellular? Is it 4G? What's the plan to 5G? All of that then, of course, then talks to a head-end system. The head-end system then is integrated with an MDMM system. Sometimes the provider can provide both of those things. From the meter data management infrastructure, then there's usually integration into a variety of different systems. At a minimum, it's usually billing, and then some type of customer interface for people to actually pay those bills, see their usage, etc. So this is a really kind of common, generic kind of version of architecture. But what we're quickly finding out really in water AMI is that those decisions are made in isolation. And so we always ask the question, well, Okay, that's the technology, but how are you going to manage the actual install of those meters? How are you actually going to maintain them ongoing? And then finally, well, the AMIs is just one piece of the water network. How are you actually viewing all of your water meter or your water assets in one kind of visual itself? If you go to the next slide, Madison. And so this is where we talk about the operational gap, right? How do you close the operational gap? As I mentioned over on the left-hand side of this slide, the decisions are made around meter installation, comms, head-end systems, billing, etc. But operations is often an oversight. Those things are added later. So things disconnected tools. One contractor's using one tool, another one's using another. There's no visibility into the real time to what work's actually being formed, especially during an install. You have visibility into actually the meters that are being installed. Everything turns into kind of reactive maintenance then, just trying to fix things. And then the resolution is often quite slow because you don't have real-time feedback in order to actually implement new processes, new policies to avoid mistakes in the field. So if you actually incorporate a lot of the operations up front in terms of your design of your AMI network, you can cross that gap to really have one centralized operations platform in which day one, you've got a standard methodology for doing the installation. Then once it's installed, well, what are the things you need to do to maintain that? How do you have standardization around inspections and replacements, investigation of processes to get ahead of maintenance issues in the future? And then when you combine all those together in terms of a total operational view of your entire water network, so the operational platform really connects the systems, the enterprise systems, and the AMI system to really the people, the work, and the decisions that need to be made going forward. So in this webinar, I'm going to turn this over to Charlie, and we're going to specifically talk about install, maintenance, and an operational command center. Charlie?
Thanks, Jeff. So, to highlight a couple of points that Jeff made, in our experience, the work does not stop when the installation is done, and we've seen this. Sometimes installation is a bit like hiring someone. It's like the circus coming to town. After the circus is over, they fold up the tents and they leave, and then you have to maintain this network. And you might have dissimilar attributes in the field, dissimilar equipment. You might have some AMR, some AMI, different vintages of gear, and then you kind of leave the work for the customer. And our approach has been a bit different, as Jeff mentioned. It's more of a platform first. Many of our customers that have had the most success in any kind of project started with our platform. And even before installation happened, we were helping them digitize the planning stage if audits were necessary, inventory of equipment and gear, and through installation and maintenance. And then after, as part of maintenance, is how do you triage issues and alerts and alarms? And then how do you bring customer data back into the mix? One platform that's holistic and it's evergreen, and it persists with the customer long after the initial installation is done. However, let's start here with installation. Let's assume we're going to jump in right at the installation part where other work's been done. But in this case, we are platform first, and also our platform is mobile first. We focus on operational workflows. Anytime someone goes out into the field to do any type of workflow, we help configure that workflow specific to the crew skill sets, the crew types, and make sure we manage that through, because when they're in the field, that's where you're capturing true field truth. And field truth, we find also needs to be immediately incorporated into the back office. If you noticed earlier, Jeff showed a schematic, which is typical, which kind of shows more of a serial flow of the data from one system to another. And we'd say every time you are serially pushing that data into the back office or into one system, and then that one system pushes it into another system, it's like a fumble or a potential fumble, a handoff, because you could lose data in the process. So our approach is a bit more hub and spoke, where all field truth, all workflows in the field, that is truth that needs to be pushed immediately into the back office. So we capture field truth with configurable workflows, And these workflows also address issues in the field where your GIS may not be fully accurate. So what happens when an installer, especially a third-party installer, goes in the field and what they find at the site is not exactly what they thought? They may or may not have the right gear. What they see in the pit is not exactly what your GIS said was in the pit. Maybe they don't even have the right skill set to fix, repair, or remediate what they find. Can your workflows adjust in the field so that if that happens, without sending another crew with another skill set or other tools, can you capture that change in the workflow dynamically in the field so they can get that remediation done, or capture the different assets that they found that were not part of GIS that was pushed out to them? Can you do that dynamically so they can complete the work with one truck roll? And then immediately that data flows into the back office systems. It flows back upstream because, as you know, once you've done an installation, as work continues later, and we'll talk about this maintenance work, every time additional workflows happen in the field, assets in the field can change. Do those changes reflect back into your GIS system, into your billing system, into your customer information systems? So that's kind of a key part of what we do. And although installation seems simple, it's important to capture that in one seamless workflow that is integrated directly into all the other systems that are important, especially across different vendors. You may have a partial AMR and an AMI deployment. And so you have different vendor solutions in the field. So we try to, that's where configuration really has its power. You can create configurations so that if these things are found, these exceptions are listed at the bottom, you can immediately pivot in the workflow to different stream that is necessary to do that remediation or capture that new asset data and still get that workflow done. And this is why we say you deploy with confidence. So let's go to the next slide. I think we can explain that a bit better. How do you control your deployment? You have your own crews, you have third-party crews. First, we say they need to be on one platform, regardless of who's doing the field work, one platform, so you have integration across the enterprise, and that every crew has what they need. Another thing that we've incorporated in our platform is not just completion of the work order and then moving to the next site, but incorporation of other attributes like imagery, photography of the site. We can apply AI tools to validate that what they said they did in the field, with what tools, with what gear, with what hardware, is really captured there. And you can see that through imagery, and you can actually dissect and disaggregate that imagery with AI to validate the work that was done. Also, when you do it this way, QC and QA is actually part of the deployment. Oftentimes that's siloed, and that's something that another crew does to validate after the work, to verify that the crews did the work correctly so that they can get paid. Our platform allows QA and QC to be dynamically handled at the time of the field workflow. So as you complete the work, you have validated the work was done correctly, you know what the GIS should report going forward, and you can actually validate to the crew, to the individual, what work was done, what their productivity measures were for getting the work done, as they said, so that you can actually close the loop on payment and on your project, keep your project on task. Let's move to the next slide. Maintenance. So as Jeff mentioned before, we see these different roles often siloed. In many cases, the maintenance work is done by the end customer, the utility, the city, not necessarily the contractors that did the installation. Our platform includes maintenance workflows integrated with deployment workflows. It's the same platform. And this is important because, as you know, the project is not complete at installation. Really, much of the work going forward to manage the new platform and manage your O&M costs out of it, down, is actually done as part of your ongoing maintenance. The other thing we'll talk about in just a minute is that maintenance digitized, or is the maintenance, whether it's scheduled by time based or by condition based, is that somewhere in a Outlook calendar, in a spreadsheet assigned to different crews at different times and somewhat disjointed, and that introduces opportunities for errors. Excuse me. So one of the things we talk about with our platform is our platform does not leave when the installation is done. Our platform is an evergreen platform. It stays with the customer. It is used at the start, through the installation, through the maintenance, and beyond, so that the customer can always maintain their operations with the same consistent platform approach. Let's go to the next slide. This gets in a bit more detail. Everyone knows about reactive work, where you get an issue, you've noticed an issue at your command center, or you've got feedback from customers, issues that they've noted in the field. Um, Preventive work, again, back to schedules around maintenance. Predictive work, where you think, okay, in this area, for whatever reason, we see more challenges. There's pressure readings that seem a bit off or odd. Other disparate sensors that are feeding data back to try to look across the asset class and see where you might want to do predictive work. We do not see these three elements as individual elements done by different crews at different times. These three elements are really integrated in our platform so that they can be done together. The point I'm making here is that what you do reactively, that history of workflow should be captured, digitized, and should feed into your plans for preventive maintenance and even predictive maintenance. So the three of these things are linked together. Every time field data is captured and other inputs are brought in, like pressure inputs or leakage sensing inputs, um, all that data provides context. It provides perspective, which should inform your preventive work and your predictive work going forward. And this is a key point that we see oftentimes forgotten or lost. Customers will deploy, they've got a new system, and yet their cost of maintaining the system going forward does not drop. In fact, in some cases, because of all the digitized alerts and alarms and issues that come up, they might be responding to more signal and noise and running trucks where perhaps they did not need to run trucks. So what we do here in this case, by combining these three elements into one platform, we try to help the customer separate signal from noise. Smart systems create more data, not less data. But some of the data without context would result in an inadvertent truck roll that was not necessary, or going to the wrong site to remediate an issue than where the cause truly would be. So we find that this is a case where you've got to look across the breadth of all these inputs, take that data, we wrap business rules around that data that's coming in to try to triage and move from noise to what is truly signal. What should you roll a truck for? Again, if it needs a truck roll, if it needs a field workflow, that's where our platform really shines. But not every signal, not every bit of noise, not every alert or alarm should result in a truck roll. So our platform has been shown to reduce the O&M cost of maintaining the system well after the new gear, the new AMI equipment is installed.
Hey, Charlie, as you talk about that installation to maintenance transition, I'm thinking about all of the kind of current water AMI RFPs that are on the street here in the United States right now. And, if you look at those things, as we've talked about, the installation side, right? A third party is responsible for installing these things. They're bringing their own software. Um,
Mhm.
there's no standardization around what software they're using, what data they're collecting. Once they install it, they're supposed to be reporting, but it's really high level reporting. And it's not real time either
Right.
in terms of providing the utility, the view back into this stuff being installed in real time. There's no ability to capture new information like what's on the ground. I couldn't install the meter for this reason. Here's an additional problem. There's a vegetation issue. There's no ability to how to capture that information. And then as the installations are going on, then the installer has to provide that data in some format back over, usually in like a CSV or some type of GIS oriented format back over to the utility, who then has to import that data into their system. And then hopefully all the data is mapped correctly and everything works together so they get the information. They obviously get the information from the MDM around things like
Mhm.
the head end system, it's communicating, and there's data flow. But usually that's separated from what was the work the installer did? Was it actually successfully installed? The reason
Right.
I bring that all up is because I think this is where this maintenance comes in is so important is everything that could have been captured and validated, as you said, at the install, it's just all lost when the next crew, whether it's the in-house crew or another third-party contractor who's doing the maintenance, there's no access to history and dates and logs and
Right.
previous concerns about this particular, let's say, residential meter in this location. It's just all gone for the new guy to learn it all over again and again, not capture it. So I think that's where this installation of maintenance transition is so incredibly important. Instead of utilities putting it on the installer, well, use whatever you want to do, they provide a tool like TerraGo. This is the tool that you'll use. This is the process and the data that you're going to capture. So they've got that clean handoff going from one crew in installation to the other crew doing maintenance.
In fact, a point on that I'll make a kind of to sharpen that point. Wouldn't it be nice if your maintenance crews that would go out to the field to resolve or remediate some issue that when they saw that what was in the field was not exactly aligned with what GIS gave them, would it be nice if they actually could bring down in a cache file the previous field history for perspective to say, oh yes, I can see now the perspective they have is they could see that 3 months ago this work was done, or 6 months ago this work was done, or these are the issues that over the last 6 months, 2 years. Sometimes that will inform how they got to where they are today. Sometimes they may look and say, well, why is this built this way? Why I was expecting this meter or this endpoint, I was expecting these conditions. This is not what I found. Well, what did the last person do? And when was that done? And what did they replace? And being able to dynamically access that data in the platform and pull that into a mobile device to have a concise view of the work history often provides perspective to say, oh, I see now what happened. And that helps me understand how we missed that and what I can do to truly remediate and provide the maintenance that's required, and then capture that data, and it goes back up into the platform again. This platform gives access to all that data with context and perspective, not just raw data, so that you can make the best decisions while you're out there on that truck roll in front of the assets to be remediated.
I think the
That's a good
important thing
point.
that you mentioned on all that is again the flow from our platform back up into the enterprise systems.
Yeah,
Unlike a lot of processes that we see today where, it's notes on a work or a work order or a call log somebody took saying what work they actually performed, and somebody going into some system. Whatever work is actually done, like a new meter installed, that asset information on that meter flows through TerraGo back into the primary asset management system and or GIS system to update those systems in real time. So there isn't a human involved in updating attributes in some back office enterprise system.
right.
It flows through TerraGo back into the back office of the utility. Great. You want to move over to the next slide and talk about Command Center?
Sure, let's do that. So this is a very visually rich view, but the point I want to make here is that as you look across the whole network, and imagine that this is a dynamic platform visualization layer. It had not just the premise information, but also had other points along the network where you're monitoring leaks, you're doing acoustic leak detection at other points and water mains or other parts of the system, not at the customer prim. You've got other sensors, pressure sensors. bringing all that data back to look at your water model. And the other point I want to make here that's sometimes lost, and we see this a lot in our other deployments, is you see at the very bottom right, these customer issues. Now, everyone that says customer portal, well, customer portal is a term that could be applied many ways. Customer portal in our platforms have two-way communications. One way is pushing data out to customers, which could be as simple as there's a boil notice for the next 4 days, or our crews will be on your street, maybe tearing up the street a bit next week. You may see some sediment come through your system, or a push notification that your bill is running significantly higher than your averages per month, but also is ingesting data. We find that one of the big misses in many of these deployments is the ability to ingest data from customers where they've detected things. Maybe it's leaks or floods or odd pressure readings. Can you ingest that data, compare that to the data you have from the sensors you have in your system, and validate that? And even let customers know, thank you for bringing that to our attention. Do you want to be notified when we have this remediated and be able to push a notification when the work is done? Many systems we've seen, the ingestion of data from the customers, the endpoints or along the network is not automatically, but it's not automated with your systems of record. It's not automated with your sensors. Sometimes if you have a sensor, you already know there's a pressure problem. Thank you, Mr. Customer, for letting us know. You can validate that input with the input you already have, and now you've got a double validated issue where you know there's an issue in this area and where it's located and what customers are affected. Many times people call call centers, that data, that information is logged. Thank you very much for calling. It's not incorporated with all the data that you have access to throughout your network. So I'd say a part of this that is sometimes overlooked and missing is ingestion of the data from the end customer as well as the data that you have about the system. It really informs the whole view. Can you see that visualization on one pane of glass and just know in these areas we have some other issues to resolve? It could be more than one customer prem. It could be a section of your water network, and now you've helped identify kind of where the issues are affecting customers and where they're not. And that gets to this idea of risk mitigation. There's always more work to do than you can do serially. You have to prioritize the work by the severity of the alarm, the alert, the issue, how many people are affected or not, what part of the network is impacted. So this risk mitigation around prioritization of the work that's in front of you can only happen when you have all pieces of data all normalized across the enterprise on one pane of glass. And then you could actually apply business rules to orient and organize that work so you get the highest value work done with your crews thereafter. That's why our platform is used and it stays with the customer because it's sticky. They find that they need it because it helps them manage the O&M costs going forward. Let's move to the next slide, and this is the last slide I have. Is so once you have that one pane of glass, that field view, and remember we support both that pane of glass to the back office, but also how that translates into mobile, native mobile applications that run for organizing the field crew. You never want the field crew to see everything you're seeing. You want them to have a very succinct, curated list of workflows that they can operate against while you see that data in real time as it comes in, and you compare it to the wealth of data that the back office sees well beyond that customer premise. And this is what provides, again, this performance monitoring, risk assessment, prioritization of the work by crew, by type of work, by what part of the system that you're having to focus on. And you can see more chronic issues across the enterprise versus point issues at each customer prem or each location where you're taking some type of sampling or measurement. So it's a full view. It sounds so simple and straightforward and necessary, but to be honest with you, it's a bit like common sense. It's not commonly held. This is something that most people need. They would say, absolutely, I'd love to have this. But when you disassociate installation from the rest of the operation of your water network on multiple platforms, disparate systems, you don't normalize data across, you really have a difficult time managing through your spreadsheets and your different systems to figure out what's really going on. How do I prioritize the work? Why are my O&M costs going up after I've deployed new technology, not going down? Are customers happier or not? Are they seeing benefit to the technology investments we've made? And this is why our platform has been used extensively by a lot of many cities and utilities across many asset types. And I guess I'm hitting this point hard because it sounds so straightforward and necessary, but it's just not commonly done.
Great.
Go
Thanks,
ahead,
Charlie.
Jeff.
Think to kind of wrap up this discussion, wouldn't be a true webinar unless we brought up outcomes or ROI. And when you look at something like water AMI, specifically a water network, and the buckets that we just talked about, you look at deploying and install, it's really about trying to achieve fewer installation exceptions, right? Give the tools to the team so they can install it once and install it correctly. I mean, we've heard so many stories about specifically water MI being installed one after the other, but there's actually a communication issue in the field. And so those water meters actually aren't talking to anything because they couldn't talk to the water network. Well, the guy should have known that at the time that he installed the first one. So he's not just repeating the process over and over again. They need to address the communication problems or challenges during that installation. So a lot of it's about giving them, again, the tools at installation time to work through and do the job right the first time. This is Charlie's point on really doing QC at the same time that you're doing installation. So that way you avoid all of this contract or rework, sending out other crews. Obviously, since water AMI is all about data to billing, right? It's like, well, if everything's up and running faster, obviously you're getting to billing much faster. And then the really big one, which is hard to quantify sometimes, that's about really creating trusted asset data. So that was my comment earlier about, well, when they're doing installation, what other information do you want them to validate? Address, physical location, lat and long. Again, you want to make sure that you've got the right meter data captured. What's the make? What's the model that's being installed? What's the endpoint that was installed? You want to make sure you have all that information so those back office can be updated so you've got the real live data and not something after the fact that somebody's got to figure out how to upload into a back enterprise system. So that's kind of one aspect of deploy and install from an ROI perspective. Obviously, from a maintenance standpoint, it's about reducing truck rolls. It's what it obviously is. Instead of constantly sending out, how do you actually organize work orders based off the type of work that needs to be performed and or the location of the work so you can get more of it actually done to shorten those response times, have greater customer kind of satisfaction. And then, kind of the final kind of ROI from an operation standpoint, it's all about just running a much better network, running a much better operational aspect in order to, again, turn all of these alerts and issues and problems and maintenance actually into action that can be resolved kind of quickly. So we talk about it in terms of our platform of kind of closing the loop, right? From all of the problems of how to detect issues, prioritize those, assign them, get them completed and done, and then make sure whatever work was performed is synced back into those back office systems, and then constantly learn as you go along. Oh, you know what we should have done? We should have collected this information, or we should have validated this. Well, iterate, make changes to that process in real time so you can the next day comes along, you can capture that information and continually improve your data. So again, there's a lot of hard and soft ROIs when it comes to an operational platform. Very hard ROIs, things like fewer truck rolls. Sometimes it's hard to really, properly quantify, happier customers, especially in the residential standpoint and or commercial business customers as well. But again, when you're looking at outcomes for every one of these things, if you're actually controlling and managing this whole platform and others are all using the exact same platform, you finally have the visibility, the analytics, the data to make more informed decisions. And that's what that whole closed loop aspect is all about. Charlie, any other comments about this slide or something I forgot?
Yes, yes, I do. And we're seeing this in other asset classes, and I think we're beginning to see this in the water market as well. But historically, when customers, meaning cities or utilities, had to make a choice of new hardware, a new vendor to deploy new technology, it felt like it was a Boeing versus Airbus decision. You had one decision, you had to choose one vendor because you couldn't afford to have more than one vendor solution on your network because each one has their own disparate systems that don't talk to each other. Our platform is vendor agnostic, and we've seen in other markets where it has been giving is giving the customers a ton of supply chain leverage and visibility. What do I mean by that? Imagine that, in the we've seen this in the grid space in droves, being able to deploy more than one vendor solution based upon the type of meter, the type of customer, sometimes separating out industrial customers, commercial customers, residential customers with different types of vendor solutions, which would be a complex nightmare. However, if you have one platform that can manage across that and normalize the data from three different vendor systems or three different sets of hardware, then we've abstracted out that complexity away from the customer. And the other thing I mentioned this for is that in the water space, many customers are going from AMR to AMI. And so if let's say this is a 2-year project to get deployed, that means for 2 years, you will live with two different vendor solutions, AMR and AMI. And you'll have alerts and alarms or maintenance issues around AMR before you can get it changed to AMI. So now you're running two separate systems in the background and had to log into two separate set of solutions. How do you integrate that into one GIS system, one billing system? It becomes very problematic. Our platform has enabled customers to, again, we've abstracted out that layer of complexity so they don't have two or three different software packages to install or to log into. They have just a Tegra application. And what we find is our APIs can collect data from those disparate vendor solutions and push commands and other data into those disparate solutions without the customer having to worry about that complexity. As we've done this in the other asset classes, we've enabled customers to not have to make an all-in decision on one vendor. Now, the way I know this is an issue in the water market is I see a lot of big deployments that start off with pilots of three vendors, which get down selected to two vendors. And finally, there's a bake off and one wins it all. And it's a mixture of AMR, AMI, different vendors. And it's because they're trying to minimize the risk of making the wrong decision where because they don't have the flexibility to have more than one vendor solution on their network because of the complexity. If we could manage that complexity operationally away from the customer, they would be able to enjoy much more flexibility on making a decision and actually use different vendors where they're appropriate. One vendor may be wonderful with gear for commercial properties, but not so good at high volume for residential properties. Well, that's an issue that the other asset classes we've seen in street lighting and electric grid and other devices and other asset classes for the same customers. We've kind of bridged that gap that we've enabled them to do risk mitigation there, and they've gotten much better outcomes. And that absolutely feeds into the O&M cost savings. It really was the supply chain hiccups of a few years ago that really caused a lot of customers to think there's got to be a better way. And our platform really benefited those customers significantly. And now they found the better way is I don't have to make one decision that's a career decision for one vendor for the next 15 years. I think that's something to be considered by customers as well.
That's a really good point, Charlie. We should have brought that up early that, it's so much about the reality of water deployments because there's so many more, as you say, in the supply chain, there's just so many more manufacturers or vendors that you would see in other asset classes like AMI and the electricity side. And so, again, you think about some of these Oh, these big water AMI RFPs that are out here in the United States, it's even more complex than just AMR to AMI. It's AMR where there's a whole bunch of different AMR vendors that are actually in the ground today, and some of those are going to just be retrofitted with comms modules for some of them, but the others are going to be replaced, and then
Right.
there's going to be multiple vendors used for the replacement for new meters. So now, as you pointed out, from an operation standpoint, well, see, I got to log into this system for these types of meters and this kind of system for these new meters here. And then, oh, yeah, the retrofits are over here as well. Instead of unifying that, bringing that into something like Terrago, so you can actually see the whole operational view, regardless of the state of AMR, moving to retrofit, moving to a brand new meter type, as well as, the different types of new technologies that are coming from these
Right.
AMI meters in terms of the measurements and data that they're bringing in that the old AMR meters certainly can't provide, um, uh, leak detection among many other things. So I think you're totally right. That's a really good point of due to the complexity of all these vendors, being able to centralize that from an operation standpoint is a huge, huge advantage.
In fact, to further illustrate that point, one of the issues that customers have, we've seen, is that new technology comes out. Well, gosh, a year ago, I just deployed this technology. I've got to wait for it to be fully depreciated. I can't incorporate it into this platform. In the other asset classes, that's not the case. They can incorporate it right away because, again, they're using an operational platform that's agnostic to the hardware. Now, in Europe and other places, we all know that there are large water utilities like Thames Water, huge, millions of customers. In the U.S., it's city by city. There are very few large water utilities, and so there's no scale where a city has the benefit. I mean, they're not buying 3 million, 5 million devices. They're buying 50,000 devices. They don't get economies of scale. So this idea of having a platform that's agnostic to the end device that can incorporate different vendor solutions in one platform is actually more important in the US as well. So that's another consideration that we've seen, and because it's played out in other markets that are just a little further ahead of the water market than we see here.
Great. All right. Charlie, I think this was a
All
good
right.
discussion. Hopefully, our participants found some use out of it. Madison, why don't we turn it back over to you to close it up?
Yep. Thank you so much, Charlie and Jeff. That was a great presentation. And thanks to everyone for taking the time out of your day to join us. If you submitted a question, we will be in touch shortly, and we'll also be sending out a full recording of the webinar after the session. In the meantime, feel free to reach out if you have any additional questions, and have a great rest of your day.
Thank
Thank you,
you.
folks.